Excellent. Welcome to the second annual Business and Generative AI Workshop. I'm Lin Wu. I'm a professor at the Wharton School in Operation Information Decision Department. So today, I will introduce you to our keynote speaker, and afterward, we'll have a general conference announcement. Okay. So it is my distinct honor to introduce a mentor, a visionary, and a leader in the field of digital economics, Erik Brynjolfsson. As someone who had the privilege of being his PhD student, I can personally attest to you his profound impact, not just academia, industry, but all of those who had the privilege to work with him. Erik is a pioneer in the digital economy, AI, and the future of work. Currently, he is the Jerry Yang and Akiko Yamazaki professor at Stanford, and also served as senior fellow and the director of Digital Economy Lab at Stanford HAI. His groundbreaking research has fundamentally shaped our understanding of how digital technologies are transforming businesses and societies at large. Beyond his numerous accolades and some of the books you've probably read, The Second Machine Age, personally, it was my favorite book of all time. And he continues to challenge us to think about how digital technology is shaped, such as generative AI, is shaping our lives. Today, Erik will share his insight on AI awakening. I'm personally really excited to see that talk, because even after almost 20 years of working with him as a PhD student, I'm still super excited to hear him talk, because they always inspire me to give me new ideas. So it's my great pride and with admiration, I ask you to welcome Professor Erik Brynjolfsson.
Thank you, Lynn. It's such an honor and pleasure to be here and have a chance to talk to all of you. And that was a very kind introduction. To the extent that I've had some success, I owe it very much to Lynn and the other students that I've worked with. It's my favorite part of my job. Like Wharton itself, I moved out here to the West Coast a few years ago. So you guys Wharton has a base here as well. And like all of you in the room, I've been focusing more and more on AI in my research. And so what I thought I would do today is talk a little bit about the big picture of what AI is, what sets it apart, what's different, especially about recent types of AI, the implications for the economy, dive into a little bit of the research, some examples of AI, especially generative AI, changing work and productivity, then step back about some of the research questions and broader implications. I'm going to try and do all that in sort of like the first, 40 minutes, because we have an hour, I understand, and the reason I'm here is because I want to interact with all of you, and there's so many smart people in the room. I want to leave, maybe 20 minutes for questions, so feel free we can go broadly when we go to the questions. There's lots of different topics we can touch on. I think a good structure is maybe as I do the presentation, if you have a question that's sort of narrowly related to the presentation, then feel free to ask it then. If you have some broader questions, we'll cover them a little bit later. So let me start off by, let's see, here we go. By first, I think AI is the most important technology of our era, maybe of all time. And that's because AI is a GPT. And in this context, GPT means general purpose technology, not generative pre-trained transformer. It sort of sucks that the AI folks have stolen that acronym from economists, but and it ticks all of those boxes that Tim Bresnahan and Manuel Schachenberg defined of being pervasive, able to be improved over time, and able to spawn complementary innovations. And the reason that's important is because GPTs basically is what drive the economy. They drive economic growth, steam engine, electricity. They're the most important technologies. And AI is the GPT of our era, of our generation. And I don't think it's an exaggeration to say that AI is the most general of all general purpose technologies. Because as Demis, if you guys have ever visited King's Cross DeepMind over in London, they have this modest little slogan there. Our goal is to solve intelligence, and then to use that to solve all the other problems in the world. So I'm sure each of you has a personal mission statement that's equally modest. But there's a lot of truth to it, right? Because if you can really solve intelligence or make big progress in intelligence, it's going to allow you to do a lot more with health and longevity, with the environment, with living standards, poverty, even governance. There's so many things you can do better with more intelligence. So that makes it a very powerful technology. And the good news is that not only is it a general purpose technology, but it's one that's improving incredibly rapidly. So I don't know, like 8 or 9 years ago, we started this thing called the AI Index because there was no one place to see all the progress and all the evidence on that. And so here's one of the charts from our latest report. You can go to the website there and download about 520 pages of charts like this that try to assemble. We try to do some curation and a validation of the data to see how things are progressing on technical, economic, social, academic, lots of different metrics. And here's one that, that I asked them to put together because it was scattered across a lot of different charts. But putting on one chart for you guys, you can see the rapid progress on lots of different metrics. I mean, like even the first one, their image classification, that's actually quite a dramatic change. With ImageNet, it used to be that you could barely use it as recognizing images, and now it's in many applications better than humans. I put that dotted line there because it has a lot of economic significance when a machine can do something better than a human. We're going to talk later in the talk about some of the pluses and minuses of thinking about it that way. Now, why are these lines not only going up so steeply, but if you look at them, they're kind of going faster and faster over time. So what's going on? Well, I think it's very useful to have a framework for what's different about AI and what's new in the world. So Lynn mentioned my book, The Second Machine Age, and with Andy McAfee, we thought a really important fact was that earlier technologies like the steam engine, et cetera, were focused on basically augmenting our muscles, doing physical work, moving atoms. And the second machine age was about having machines of the mind that could augment cognitive capabilities. But for most of the past 50, 60, 70 years, that revolution has focused on a particular kind of machine, one where you teach the machine what to do and then it carries it out. And this is true in regular coding. It's also true in the early days of artificial intelligence. I'm old enough that when I first started teaching courses on AI back in 1988, I taught courses about expert systems, rule-based systems. We would hand code a lot of different rules and then have the machine carry them out. But we're now in a new era of machine learning. Machine learning was always around there, but it wasn't really very powerful until recently. Machine learning is fundamentally different. And the reason for that is if you think about how the technology works. Ilya Sutskever calls it software 2.0. Andrei Karpathy. So diagrammatically, and this is an important point, is that most coding that you guys have all done, we all do, you take a set of inputs and you write down a program, a set of instructions, and then the computer figures out how to turn that into outputs. You have to know exactly what the instructions are. If you're doing, I don't know, tax preparation software, if you have a comma in the wrong place or you put the word a little bit wrong, it's going to give you the wrong answer. So you really have to know exactly what the steps are in your process. Now, the good news is that still covers a lot of stuff. There's billions, not trillions of dollars worth of value in this paradigm that has been created. And once you've codified it in f of x, you can digitize it and then replicate it and scale it to tremendous value. But I'm calling it the old paradigm, even though it's still growing, taking over more and more of the economy. Was Mark Andreessen says it's eating the world. The new slide, software 2.0, is different. Instead of inputs being applied to a function, you give it inputs and outputs from training data, and then it figures out what the function is. So this is a new way of writing software. You don't have to know what the function is in advance. It can take tacit knowledge. It can take patterns in the world and learn what's going on. That's why it's called machine learning. And of course, once you've got that f of x that has been learned, now you can go back and do inference on it. You can apply it. So there's these two steps. You learn it, that's the training. So all these models, you've heard about them being trained on huge sets of data, very expensive. But there's a second step, which is inference, which might run on your smartphone or your local computer, where you then take that f of x and you learn new, put in new inputs and get new outputs. So this new paradigm, people are fiddling around with it for decades, but now three things have changed. One, we have much more computer power, like millions of times more computer power than people did a few decades ago. And it takes a lot of computer power to do these inferences. We have much more data. We didn't have a lot of digital data back before the 1990s. Most data was analog, and you really need huge amounts of data. And finally, we have some improvements in the algorithms, and those are also important. But all three of those things have been improved by many orders of magnitude, and it's taken something that was an idea and made it something that's incredibly powerful. And one example that Andy and I wrote about in the Harvard Business Review was just all these places. Every company you're working with has dozens of examples of inputs and outputs, and they almost surely have lots of places where they can apply this new paradigm, software 2.0, to make new diagnoses. Joshua Gans, Avi Goldfarb, and Ajay Agrawal, you're talking about prediction machines. That's basically what it is. It takes inputs and predicts outputs. But now we're in a third wave, which this conference is about, which is the third wave of the second machine age. So it's not just we have to have instructions or learning. Now it's actually machines that create stuff, generative AI. And it's happening. This one is catching a lot of people by surprise, including I walk around the halls of the Gates building at Stanford where all the computer scientists are. I moved my office there from the economics department because I wanted to be close to them. And I asked them, and they are genuinely surprised. And one fun way to see the surprise is just look at how popular culture imagines. So I think most of you have probably seen iRobot with Will Smith. And there's this iconic scene there where he's trying to give the robot a hard time. He says, well, can a robot write a symphony? Can a robot take a blank canvas and turn it into a masterpiece? And in the movie, it's obvious, robot can't do that. No way. I mean, that's ridiculous. This was actually supposed to be set in Chicago, 2035. And so, of course, the robots, can't do that. So, humans are better. Well, if they were to do a realistic version of the movie, not in 2035, but in 2024, the robot would say, yes, yeah, of course. It can do those things and a lot more. So we are ahead of schedule in terms of what even science fiction writers were imagining. And that makes you think a little bit about what's happening in the world. And I will talk towards the end of the talk about how we as researchers should update accordingly. Now, it's not just fun science fiction-y stuff. There's lots of quantitative data. Eric Horowitz and Bubek and the others at Microsoft had this nice paper, Sparks of AGI, 100 pages of charts like this one that I'm sure you've seen about that these can now do the SATs or the PSATs or the GREs or whatever test you took to get into grad school, as well as 50% or 90% or more of humans. And that's an interesting benchmark. And we could have a lot of those sort of tests, but we all know that academic tests are not a good measure of real practical value, right? So we want to look at some of the productivity effects. And so let me take a chunk of time now to talk a bit about the work that Lindsay Raymond and Danielle Lee and I have done on call centers and dive a little bit and happy to take some questions as we go through this. But this was a nice natural experiment that allowed us to really tease out the effects of generative AI on productivity, on the workforce, on learning speed, et cetera. And the way it worked was that Cresta, a company started out at Stanford, introduced this large language model based on GPT, basically. And they helped call center agents answer questions better. They didn't try to replace the agents, they augmented them. We'll talk about that a little bit more later as well. So a customer might ask a question like it says in the red there, and then the human agent would get a hint from the system. And the human could just take that and just use the system answer. It could edit it, which they often did, or they could they could ignore it and they could just give their own answer. And they did that frequently as well. But the human was ultimately in charge. And I love research where you don't have to do a lot of fancy econometrics. So this was a pretty clean experiment. So you could just look at the raw data right off the bat. And so I knew we had something interesting to go when I saw this. I was like, we got to write a paper about this. On a whole bunch of different metrics, we immediately found that this was before and this was after. You could just see there was a noticeable shift. And that's statistically significant on the number of resolutions you can do an hour, or how fast you can do them, the number of chats you can do, how likely you are to resolve them. If you want to do a little bit more econometrics, you can do difference in differences, and it's a pretty clear jump there. There's these wars going on in the credibility revolution about how to do differences and differences. I don't know who's right and who's wrong, so we just did all of them. And no matter how you slice it, whatever methodology you do, you get a clear result there. So that was pretty clean. Lots of different KPIs, lots of different metrics of productivity improved quite noticeably when they had access to this tool. We also saw a lot of other changes that happened. For instance, you could measure customer sentiment. You guys have probably had fun doing sentiment analysis. You look at these millions of transcripts, and there's a lot of words in there, and some of them are happy words and some of them are angry words. Customers, there's a whole range of different sentiment in the customers. I was hoping to be more variation in the agents, but it turns out all the agents are very, very nice. So, well, almost all of them. So there's not much variation on the agent side. So what happened when you introduced the AI system? Well, customers got happier. They were nicer and they were more likely to be happy and satisfied, at least according to the way that they talked. So that was a good thing. Agents, it was hard to tell. And I think this is just because, like, how much happier can you get than what they already were? So there wasn't much room, or at least in their words. I don't know what they really were in their heart of hearts, but in terms of how they're talking. If you squint a little bit, it looks like maybe agent sentiment went up a little bit, but it was already close to being maxed out. So we're seeing a change in the way that they interact. I think one of the most interesting results was the different effects across different people, because I've been studying IT on productivity, on inequality for, well, many decades. And the prevailing paradigm was skill-biased technical change. Tim Bresnahan and I wrote a paper and Lauren Hitt a paper in the late 1990s about how IT tended to be associated with greater benefits for more skilled workers, increasing income inequality. And that was a big part of the story that, as you guys know, inequality did grow for most of the past 20, 30, 40 years. And technology has been the number one reason, specifically IT. So there's a big literature on all of that. But in this case, it was the other way around. So when we broke up the agents into 5 different quintiles, what we found was actually it was the least skilled workers who benefited the most, not the most skilled workers. This was not skill-biased technical change. This was helping the less skilled workers. If you remember earlier, the overall benefit was about 14%, but for the least skilled workers, it was closer to 30% on this metric. Some of the measures, it was up to 35%. And the most skilled workers, it's like not statistically significant in 0. If you really want to say actually the point estimate, it's even a little bit negative. It's quite a monotonic effect. It's not just true for skills, it's also true for their tenure. Newer agents seem to benefit more, or do benefit a lot more than agents who have been around for a while. So this is quite different than the other ones. And I'll show you in a little while that it's not just us that's finding this. A lot of people are finding a similar pattern. So this is just like software 2.0 is very different. This seems to be different. And I think those may be related, that I think this is able to capture some of that tacit knowledge that the best call center workers have. And nobody's ever written it down or articulated. It's not in any instruction manual, but the AI system learns it from all these transcripts, which ones worked out well, which ones didn't work out well, and then makes it available to the less skilled workers and closes that gap as a result. And if you're already on the frontier, there isn't much to learn from the system. And so that's why you get the differential benefits. It also helps them catch up faster. Their learning speed is faster. The agents who don't have access never get access to the technology. They do improve over time, but not that fast. Whereas those who get access to the technology, you see very rapidly improve. Within a few months, they're already significantly better. What is it, like 4 or 5 months, they're already, actually even 2 or 3 months, are already better than the people who don't have access to the technology. We also had a group that got access to the technology after 5 or 6 months, and they're kind of in between. Don't improve, of course, well, not of course, but don't improve much when they don't have it, but once they have it, they start pulling away. Now, one of my concerns was that this technology would become a crutch. Like if I use GPS, I start forgetting how to get places and I become very dependent on it. Or maybe people learn how to take this cube root of a number if they have a calculator that lets them do that. So you may start losing some skills. When the AI system was working, the people who got access to it became significantly faster at resolving questions. But a wonderful thing happened, wonderful for us researchers, not for the company. Every once in a while, the system went down. It just crashed. And that created a natural experiment. As far as we know, this was random, although maybe the Russians were doing it or something, I don't know. When the system went down, we could see what happened to these poor people who had been relying on the system. Were they like lost now? Well, it's kind of noisy because we don't have nearly as much data on points when they're down. But if it looks to me, if you squint a little bit, even statistically significant, that they continued to do better. So people who had been using the system, who had access to the system, they internalized some of that. So rather than it becoming a crutch, it actually was more of a learning tool. And when we interviewed the folks to understand what was going on, it was interesting. But see, before the system was introduced, they did try to learn. They would, have a week's worth of customer interactions. And then at the end of the week, they would meet with their manager, and the manager would pull out the transcript and say, over here, you should have mentioned this other product. Actually, this is a very easy way to solve this. You should have told them this. Or, maybe you shouldn't use the F word quite so much when you get angry at them. And then the customer agent would learn from that, and hopefully the next week they would do a little better. But as you can see, that's a pretty sparse, low, slow way to learn. Whereas with this system, how do they learn? Every single time there was a call, they would look at it and say, oh, here's a possible answer to that. And it's very context relevant. It's real time. It's just a better way to learn. And their brain absorbs some of that. Finally, I want to talk a couple more slides on this. I want to talk a little bit about how their language changed. So the blue dots are the people who don't have AI, and the red dots are the people who had access to the system. And we looked at the vertical axis is how similar the language was between the low-skill workers and the high-skill workers. This is a large language model. Lo and behold, it affects their language. They start sounding more like the high-skill workers. They use some of the same words. So it's not just the content, but it's sort of the tone and the types of words that are being used. And we're right now trying to sort out, is some of these workers were overseas in the Philippines. Are they learning sort of American metaphors about baseball or whatever? What kind of cultural differences are there in addition to the content differences? Yeah. Oh, yeah, sure. Go ahead. Why don't you say your name? Shai?
Oh, yeah, Shai.
Yeah.
Is that while they're using the AI that they sound more intelligent?
Yes. Yeah. So it's taking, it goes back to what I said earlier. It's taking some of the suggested things that seem to work, and now there's a little bit more standardization. So the answers are more consistent across them, and the language is more consistent.
So have you checked what happens if there's an outage or that's not?
It's a great idea. Okay, I'll add that to our to-do list. I think that's a good. The thing is, it's already kind of noisy, even just with the productivity. I'll see if we can pick up something on the language too, whether they've actually changed. Yeah, I wouldn't be surprised because they're definitely doing something different. So that's a good point. Any other questions? So finally, I want to talk a little bit about where machine learning works well and where it doesn't work well. I said that this was not replacing people, it was augmenting them. And the reason that Crusta made that choice is that they know, as it comes up over and over, that AI, awesome as it is, can't do everything that humans can do, at least not yet. And in particular, machine learning needs data. Data is the lifeblood of machine learning. So what you need to have is lots of data. And if you look at the kinds of questions, there's some questions that come up very frequently, like how do I change my password? I'm locked out of the system, where do I update? And there's some questions that only appear once or twice in the data or hardly at all. Like some complicated tax questions happen to be financial tax software. The machine learning system can't really learn about it. It doesn't know how to answer this because it's never seen it before. It has lots of data on the common questions. And it turns out that, you can imagine the machine learning system does much better on the ones they have more data for. We humans, on the other hand, can muddle our way through even when we don't have a lot of data on it. We're good at exception handling. We're good at doing that. Reid Hoffman says that's really our human superpower, is handling exceptions. So the humans are better over here. The machines are better over here. Actually, in the middle is where the machines turn out to have the biggest value because they're really common questions like everybody knew the answer to anyways. And there's so many studies. A lot of you people in your room, I should really have this slide. I should probably have like 30 or 50 studies now. But the only point I want to make is that, well, this was one study. I think the patterns that I just described, they seem to be showing up a lot. That, number one, we're getting pretty quick productivity gains. We're often having humans and machines outperforming machines alone. And we're often having, in all these studies, having the less skilled workers benefit more than the more skilled workers. So there is some evidence accumulating. I think we still have to see whether there's some, this is a universal, I'm sure it's not a universal, but how common this pattern is. Let me talk a little bit about some of the challenges that are facing and what I call the Turing trap. I am confident about AI boosting productivity. I'm much more worried, despite what I just said, about it consistently reducing income inequality. Even though it may help that on the skills side, it could shift the value between capital and labor. And capital is much more concentrated than labor. So if it shifts value over to capital, it may lead to a concentration of wealth and therefore a concentration of power. And a particularly concerning aspect of that is making machines that closely imitate humans. So you guys recognize him? Alan Turing wrote the iconic paper, the definition that's come to become a definition of artificial intelligence, the Turing test, in his 1950 paper. And it basically was based on, as it says there in the title, in the subtitle, the imitation game. And he thought that the way you should define AI is it was just like a human. Human was the standard for intelligence. And if an AI was indistinguishable from a human, ergo, it was intelligent. And I used to think that was a pretty good idea. And now I think it's a terrible idea. I don't think it's a good test at all. I also think it's even worse as a goal. A lot of people, nonetheless, are pursuing that goal. When I talk to technologists, they're pursuing it. When I talk to managers, when I talk to policymakers, they implicitly or explicitly say, let's make machines that do this. We see increasingly humanoid robots. We see machines where all the benchmarks, or many of the benchmarks, are let's see how humans are doing, like some of the ones I showed on the AI index slide. Nielsen, who was at Stanford before he passed away, basically said that the goal of what he called strong AI was that they would do the exact jobs that humans do. And I think it's tempting to go that way, but it's really not what I think we should be doing, especially now that we're getting very close to actually achieving it. And now that we're sort of like the dog that caught the car, like, wait a minute, is that really what we were wanting to do in the first place? And let me give you two reasons why I think aside from being a bad test conceptually, I think there are two economic reasons that it's really a problem. The first is that it's actually not ambitious enough. It sets too low a ceiling. If all we do is replicate what humans are doing now, take all the jobs that we're doing now and have machines do them, that's a low bar. You may think it's a high bar. I think it's a low bar. Let's think about, suppose that Daedalus, who was the mythical engineer who made the first robots 2,500 years ago or 3,500 years ago, suppose he had actually succeeded, just hypothetically, and suppose he had followed Alan Turing or Nielsen's advice. Let's make machines that do everything that humans do, everything the ancient Greeks were doing. Sounds pretty good. What would that mean? Well, it would mean that if you needed to make clay pottery, completely automated. Weaving tunics, done. Horse-drawn carts, machines will do it all. You're sick, no problem. We're going to have the machines burn the incense, just like the humans used to. Well, the good news is humans wouldn't have to work anymore. Machines would do everything. But would our living standards really be that much higher? You know, we have piles of Greek urns in the corner, and like the horse-drawn carts would always work. But you can see fundamentally that was not what lifted living standards. It wasn't sucking the labor out. It was doing new things, inventing new things, things that we never did before. So it's not enough to merely imitate what we're currently producing and do it with zero labor cost. That's too low a bar, and I think future generations would be disappointed if all we did was have the same goods, services, process, etc., but with no labor. The other reason is even more pernicious. Not only is it not enough high enough ceiling, it leads to terrible implications for inequality. And it leads to what I call a trap, the Turing trap. And it can be expressed in one equation. You guys know that productivity is defined as output divided by input. Usually that's measured as GDP over labor hours. So suppose we set labor hours to 0. What happens to productivity? Anybody do that math? Goes to infinity. I mean, that's pretty high. I don't think this can go a whole lot higher than that. So that's great. I mean, wow, awesome. Infinite productivity. What happens to labor income? Goes to 0. Well, that could be a problem if the source of income for most people is labor income. And that's how we distribute the ability to buy goods and services. So that could also affect political power. People who don't have economic power, I'm not a political scientist, but my sense is they don't usually have as much political power either. So productivity, even when it's infinite, isn't everything. You could have infinite productivity, but still have a lot of people worse off, not just in relative terms, but in absolute terms. So now you have a new question, new problem. And one of the things about labor income is it's inherently decentralized. If you don't pay your factory worker, if you don't pay your farmer, you don't pay your professor, whatever, then you don't get the output of that person. But if you don't need them anymore, then there's no economic bargaining power. You may decide to do it out of charity or kindness, or maybe there's a law that's passed and you have to do it. But you can see that this may not be a stable equilibrium where these people don't have power or we don't have power, depending on if you're a laborer or a capital owner. And so that's something I worry a little bit about, is we have to think a little bit about how are we going to have not just prosperity, but shared prosperity. So let me talk a little bit about the future and what's happening. So Gary Kasparov, he lost in Deep Blue in 1997, 98, I think it was 97. And afterwards, he's like, okay, machine can beat me, but a human and machine together can beat any machine. So he created centaur chess or freestyle chess. And this was very successful for a while, and it fits with what I was talking about, the Turing trap, having humans and machines work together. But it turns out that's not true anymore. AlphaZero is so good that if a human tries to give it advice, it's kind of like a gnat buzzing around you saying, oh, do this, do that. It's so far ahead of what we humans can do that we really have little or nothing to add anymore. Similarly with cars, it's taking a little longer. This is me and Andy McAfee in, believe it or not, 2012, in front of a Google car. I rode from Mountain View up to San Francisco in a Google car, true story. And we wrote about it in our book on Route 101. When it got to the interchange up near San Francisco, the human driver took over and kind of did around the cloverleaf and came back down, and we drove back down. The traffic completely stopped and it didn't crash. So I was like, okay, it's just about there, 2012. So it's not quite there yet, but it's getting there. And how many of you guys have ridden in a Waymo car since you're here in San Francisco? So Pankaj, how does it work?
I love it. It works great.
Yeah. I think it works great. You guys, while you're here, you should all try it. You can do it around here. I think it's pretty much there. They're going to have to scale it up. It's apparently still very expensive, so I don't think it's quite economically there, but it's getting pretty close. And they've added it to Phoenix. Maybe someday it'll come to Philadelphia and other places. I'm sure it will. They have plans for it. So we're getting there, but it took a while, and we're working our way through these different layers of automation. Hopefully you guys have all heard of, the 6 layers of automation, helpfully labeled from 0 to 5. And Waymo is pretty much over here now. You don't really need a human. It's just the costs aren't quite there. Tesla is somewhere. I have a Tesla. It's a little scary sometimes when I try to put on autopilot. I have my fingers crossed, but we had a couple of near misses. But they're trying these 2 different approaches. Waymo has a lot of technology, LiDAR in particular, and a lot more compute power. Tesla is doing it leaner, trying to get more data, and we'll see which way converges to a cost-effective version. Yeah. Go ahead, Umesh.
I ride Waymo a lot.
Yeah.
And what I've seen is that sometimes the Waymo prices now are lower than Uber.
Yeah, but they're losing money. I don't know the exact number, but I've heard, don't quote me on this, they're losing $50 to $70 per ride. So Uber did that early on too. So they want to learn. So I wouldn't necessarily go by the retail price, but cost of LiDAR is falling. Cost of compute obviously is falling. They're getting more efficient. We'll see when it gets cost effective. But you can thank the search engine revenues for subsidizing all those rides you're taking. But my broader point is that we're seeing things go through. I think here's a kind of a thought exercise for you. Imagine not just chess, not just cars, but every task in the economy going through these stages. And my hypothesis is that there's a natural progression over time. Some of them go faster, some of them go slower. If you're interested in thinking about this with me at some point, come and talk to me afterwards or send me an email. Because I think I'd like to try to create a taxonomy of when are you going to go through these faster, when are you going to go slower? Will we eventually be able to get here for everything, or there's some things that you'll never get there for? But for those 2 examples, we do see kind of some progress through these different stages. I mean, chess, they don't literally call it this, but I think you could create an analogous taxonomy. So I want to have some time for questions. So let me just say a couple of things about what I call transformative AI. Some people talk about AGI, AI that is very general. They map that onto human intelligence, which I just said earlier is not a good mapping, but I think I'm losing that war. But I would like to think of AGI as much broader than human intelligence. My prediction, you can write this down, is within 5 years, people are going to think of human intelligence as a very narrow kind of intelligence. They won't think of it as general intelligence. They'll be like, oh, humans, that's like a very specific, narrow kind. But they can't multiply matrices. They can't understand ultrasonics or whatever. So I'd say general is different. And then there's another category I'll call transformative AI, which is relevant to economists like me, which is, I'm not going to debate whether it's truly intelligent or whatever. What I care about is it changing the economy? Is it transforming almost every job, almost every task, almost every process, almost every company? If the entire economy is being transformed, I'll call it transformative AI. And there isn't a real good metric of that, but going back to AGI, how many of you guys are familiar with Metaculus? No? Oh, okay, well, you learned something. Go check this site out. It's a great aggregation place. It has a lot of different sort of predictions there. One of them they've been doing for a long time is general AI. In 2022, the prediction was we would have general AI in 2057. So whatever it is, like 30 plus years away, 34 years from then. Last year, the prediction was it would be in 2040. This year, the prediction is 2032. I just checked it this morning. So at the end of 2032. Now, the nice thing is they have a very detailed, multi-page, very detailed description of what they mean by general intelligence. It has to pass certain tests, the Loebner Prize. It has to do certain, physical tasks as well. So it's pretty well defined. And the interesting to me is how much it's just the past 2 years has come in much closer, the experts are predicting. And this is consistent with what I'm hearing when I talk to AI researchers. So it's been a real change. When it was 2057, I didn't really worry about it. People were like, oh, AI is going to be able to do everything. I'm like, yeah, maybe someday. Great for philosophers. I'm going to focus on what's happening next 10 years or so, 5 or 10 years. Well, now I can't say that anymore. Now I have to start taking it seriously. And one of the reasons that we think it may be progressing is because of scaling laws. Let me not spend too much time on that. And we have a lot of different metrics that of this. Bill Nordhaus wrote a paper where he defined 6 metrics. When he wrote the paper, which actually mostly was written about 10 years ago, he found that almost none of the metrics were improving. Even by 2021, I don't think they were improving. But along with Basil Halperin and Phil Trammell and others, we were working on a project to come up with about 60 metrics, and we'll start having a dashboard to see whether or not it's improving. It raises a bunch of questions about productivity, inequality, industrial concentration that Gabriel Unger and I wrote about less than a year ago. So that's kind of a little bit of a research agenda. But let me just wrap up by saying that the thing that I'm especially excited about right now is a project to understand the economics of transformative AI. We're calling it kind of ambitiously Project Apollo, which will define what are the economic theories, benchmarks, institutions that will govern and understand an economy where AI has much broader capabilities, maybe as soon as 2032, maybe sooner, maybe later. I'm not sure what the right year is, but if there's any reasonable probability of it being in that range, I need to get to work on that question. And I'd like to say, any of you who want to work on that with me, let me know, and we're going to bring together some folks who are interested in this kind of out a little further, not like the call center study about what's happening now or the next few years, but something that's more transformative, because until we have an understanding of those things, I think policymakers will be flying blind. And so there's some empirical work to be done. There's some theoretical work to be done. There may be some simulations and other things you can do using these technologies, and that's part of our agenda. If you want to read about any of the stuff I just talked about, in the corner of every slide, I should have said at the beginning, was a reference to the relevant paper for that topic, but you can find them all on my website or the Stanford Digital Economy Lab website, and I encourage you to take a look at them. So with that, let me just stop and see if there's any questions or comments. Thank you. So, questions. Do these mics on the tables work?
They do. Just
Okay.
push the top.
Just push the button. So let's go with somebody new, like over there in the back. Yeah. Say your name.
One
Press the
second.
button, wait for the light to turn.
Green. Yeah.
I got it. Evan Shellen, Global FinTech Forum. My question is mainly what you just mentioned about economics. And the market is down today and yesterday, and there's a fear that we're going into a recession.
Can't be true then.
But there's a fear of recession
Yeah.
coming out. So if this happens, if it comes to fruition, the question is, how long does recessions last? In modern days, since 2000, since the advent of the internet and all that, it's less.
Mhm.
3 or 4 months, and
Yeah.
it goes back again. Now with advent of AI, how do you see that coming into the market?
Yeah, that's a really interesting question. I mean, I'm not much into the business cycles and stuff. Let me just say two or three things on it. Long time ago, Alan Greenspan asked me a similar question about digital technologies just speeding everything up. Actually, I take it back. I asked him the question. I said, digital technologies are speeding everything up, and the Fed can learn what's happening in the economy much faster, and are you able to respond more quickly? And he said it was actually like a Red Queen phenomenon, that they were able to see things faster, but all the companies were able to react faster, so they weren't any better in terms of understanding where the economy was going. It was just kind of one step behind. So I think there's a sort of a arms race going on in terms of lots of people using AI. It may just speed everything up, but not necessarily improve overall ability to control. I'm not sure. Although I'm not super into business cycles, I do have a hypothesis that when you have these tremendous productivity gains, which I'm a productivity optimist, I made a bet that it's going to go a lot faster, that always doesn't always turn out well for the macroeconomy, paradoxically. You get a lot more production and prices fall, but if the Fed and others don't manage it correctly, demand may not keep up with the increased supply. And then what happens? Well, in the 1930s, what we had was a lot of farmers having excess production. They had tractors and other technologies that allowed them to, increase productivity by double-digit, maybe triple-digit percentages in some cases. So you had all this additional output, but we didn't eat like a lot more, apples and bananas and oranges. So prices fell, and they actually made less money than they did when they were producing less. I could see the same thing happening if we're not careful, that we have mass production, increase in output, and if the macroeconomy is mismanaged, not just a short recession like the last few have been relatively, but a really bad recession. So I'm hoping part of this project would be to understand how do we steer the economy in a time when we may have supply shocks that are in the good direction. Next question. How about over on this side?
Hi, Eric. This is Abhishek from GMU Costello College of Business. So my question is related to the last part of your presentation.
Yeah.
And it sort of takes an economic sense to it. So if I go with what you said in the first part of the presentation about how machines have evolved, in each of those evolutions, in my understanding at least, humans have had a greater proportion of understanding of how those machines work. So if it's a steam engine, they would know that how it works with the basic components. If it's silicon chips, they know how it works. But the part about AI that sort of worries me is, even now, scientists don't really know how neural networks actually predict.
That's right.
They don't know the mathematics of it. How does it actually work?
Right.
It's almost like a hidden throw thing that they're doing. Like let's throw many things at it and see what sticks. With that, do you think there's a need to actually first understand how neural networks work and then go ahead with the transformation? Or should we just go full steam ahead and see what sticks?
I think you're absolutely right in everything you said, and this is a real challenge that Ilya Sutskever, he has a nice little video. In 60 minutes, he can show you how to build an LLM or large model. And you write like 2 or 3 pages of code, but then you go and you have data and it trains for hours, days, weeks, months, and then it's writing all those connections in the neural nets, literally billions, in some cases trillions, and he doesn't know what all those connections do. Jeff Hinton says he doesn't understand what's inside of it. He's the godfather. They don't totally understand how these systems come to their conclusions. Eric Schmidt and the late Henry Kissinger wrote, and Dan Huttenlecker wrote a kind of a long, a little bit sprawling piece in the Wall Street Journal, like less than a year ago, where they said that there may be a new kind of relationship we have to our technology. 1,000 years ago, we were all kind of humans were all kind of superstitious. The rain came and we had like the rain god must have done it or whatever. Then we had science and we understood, okay, here's our model, and we created technologies like you were saying, okay, this is how to power the steam engine. I mean, real historians will tell you that sometimes the technology actually came before the understanding, but that's okay. We kind of figured it out. And they say that now we may be going back to an era where we just have to trust the oracle. We don't know why it's giving the answer it's giving. It's almost kind of mystical and spooky that it comes up with the answer and it seems to be right, but we don't really understand why. Maybe, and here's the weird thing, maybe it's beyond our understanding. Stephen Wolfram says that LLMs have layers of understanding of even language, our language, that no human ever noticed before or can understand, because it's on a whole nother level. So I think we're gonna have to grapple with that. I mean, one possibility is, as you suggested, we slow it down and say, wait a minute, first we have to understand it. I don't think as a practical thing that's gonna happen. It's gonna plow ahead. A slightly more feasible thing is we try to get one AI system to look at the other AI system and explain what's going on. And so they are working on that. Like GPT-4 is looking at GPT-3 and trying to explain how it comes to conclusions. So there are people doing that. But even there, it has to simplify it for us ordinary humans. And so, I mean, in fairness, humans do this themselves. Like when I tell you, why I did something, what my motivations were, I'm not sure I'm really understanding the whatever 70 billion neurons in there and how they're all connecting. I'm giving you kind of sometimes a confabulation, a kind of a story that hangs together that makes maybe sense to me and makes sense to you, but it may not get at the real, there's a layer of complexity we can get to. But It's an interesting new world we're entering with some philosophical and cognitive implications, and I think it can be a little risky too. More questions? How about all the way in the back? Yes. And just say your name. Yeah.
This is Zhen Liang.
I can't read it. But
Zhen Liang.
okay, go ahead.
Okay. Thanks for your inspiring talk. And okay. So actually, I have concern about the AI's future because according to the Approach AI's reports, it seems that AI firms will soon exhaust most of Internet's data. It's kind of there's a data wall because the speed of AI training the data is much faster than the human generated data. So if just like before 2030, most of the data will be exhausted by the AI firms. So if so, if there's no new data used for training the AI's model, the AI maybe becomes more stubborn.
Right.
So if so, I have concern about that. Is there still a bright future?
Maybe that's good news. Then we don't have to worry about the Abhishek's question. So I think there's probably, the people I've talked to, probably just the data, we can probably get another 10x to 100x through using more visual image data. And then the big opportunities in synthetic data, especially when it comes to coding and other things. Surprisingly, it seems like pulling yourself up by your bootstraps, but they can use the machines to generate coding data and then learn from that and actually do better than they did before. Use like a GPT-4 class machine to generate a lot of examples, puzzles and so forth, and then you can train a smarter one, GPT-5, to do that. This is one of the slides that I kind of went very quickly, but these are the scaling laws that you guys should be familiar with. Dario Amodi and others really pioneered them, but they seem to be holding where as you add more compute, more data, more parameters, there's a surprisingly predictable improvement in performance, or at least it has been historically, and all the hyperscalers, around a few blocks around from here, are putting in billions, tens of billions, some say up to hundreds of billions of dollars to go down this. Will we run out of data first or run out of compute first? We probably won't run out of parameters. Then that's a question. I think data is probably going to be the bottleneck, and we'll have to figure out either ways of creating synthetic data, other ways around it, or let's remember, this is an amazing paradigm. There's lots of people, more people than ever in history, working on better paradigms. You know who else is working on better paradigms? AI. So there are, systems. We may have a lot of smart AI systems also trying to come up with better paradigms, and maybe we can find ways. There are people who think that we can do, so like for instance, a large language model has all these parameters, billions of parameters. It turns out, apparently, that a small fraction of them, only 1%, are really useful for almost all the answers. The other ones are just kind of junk. So imagine if we could find a more efficient way to find that 1%. That's one example. Or imagine we do planning. Had a conversation with Bill Gates, and he's very excited about what he calls metacognition, which is, you guys know that an LLM predicts the next word. And so if it writes a 5,000 word essay, it starts with, the dog, it just predicts each word. And somehow it's like weirdly coherent, it's pretty good. Sometimes I write papers that way, but most of the time it's not how I write papers. I start with, what do? You guys, I make an outline, and then I gather evidence for the different parts, and then I adjust the outline, and then I maybe make a first draft, and then I see how it's coherent. And so if you ask an LLM, what are the 5 steps you should do in writing a paper? And then you say, do step 1, make the outline, do step 2, do step 3. It does a lot better than if it just starts with predicting each word. That's called metacognition, this idea that you sort of think about what you're thinking. That doesn't require a lot of data or that. So there are many simple things like that, relatively simple, that could, I suspect, improve performance by orders of magnitude that we'll see in the coming months and years. Another question. You guys want to pick, or there's so many people here. I want to be fair. How about over here?
This is the last question here.
Okay.
Excellent.
All right, so you said that full automation is something that we should not desire as a society. How about automating low-skill, rudimentary jobs, which are less, or I would say, not intellectually stimulating at all.
Yeah.
And the other thing is that what if some people are bent upon going for full automation, like Elon Musk and a lot of other people? And what will the world be like if they do pursue that? Who will intervene? Do you think that there has to be regulation in that side from the government and other agencies?
Well, thank you for asking that question, because I don't think we should never do full automation. Okay, so I should be clear. I think there's some dangers in applying it too many. I think there are places where it's a good idea and places where it's a bad idea. And in my Turing trap article, which I had to summarize in 2 or 3 slides, but I hope you read it because I think it's really well written, I make the argument that there are excess incentives. Right now, there should be a balance between full automation. Some places like dull, dirty, unpleasant jobs, we should do more of those, dangerous ones. But other places, it's not as effective. And I argue that technologists, policymakers, and managers all have excess incentives to push too much to one side than the other, and we should rebalance those. But I definitely think there are places we should be doing it, and I just want to see more of a balance. And I told you 2 of the externalities of an excess focus on automation versus augmentation, or substitutes versus complements, if you want to use more economic language. So there should be a balance, and I think there are many wonderful opportunities. When I talk to managers, which I do a lot, I find that most of them are excessively focused on cost cutting and automation, and that usually doesn't work out as well for them as if they think about keeping humans in the loop. As for Elon Musk, well, I think it was John Maynard Keynes who said that most business peoples are slaves to some defunct economist without even knowing it. That's you guys, that's us. So I think that if we can change the conversation and come up with a philosophy of what are the benefits and costs and come up with these principles, we may be able to get people to think a little bit differently. When I go and talk to a lot of technologists, they're familiar with the Turing test, and they're like, oh yeah, let's go and make a machine that has a 5-fingered hand and that talks the way a human does. That's just for them, that's the definition of AI that they just have in their blood. And when I tell them this other thing, I spoke at iClear, one of the big AI conferences. Jan couldn't invite me to give a kind of a keynote there. I gave this other paradigm, and all these people came up to me, and these technologists, and they said, oh, I didn't realize that. You want us to aim at this target instead of that target? No problem. We can do this target. We can make AI that augments people. We can make AI that extends capabilities. I mean, why didn't you tell us? We'd be happy to do that. And so I think there's actually much more agency in where the technology goes. And a lot of, not everyone, but some people are very open to that. They just hadn't really been pointed in that direction before. If we make a case, we can make some progress. Now, in addition to changing the conversation, we could also do things like change taxes. Right now, it's much more expensive if you have a company. A company that has a lot of human employees will pay a lot more total taxes than a company that has no human employees, just because of the way our tax system is set up. I'm not sure that's why. So the government right now puts its thumb on the scale to steer things. We could make it more balanced, or even tip the other way if we wanted to. We could change regulations, in credits and so forth. So there are other things we could do but I think even just changing the conversation is part of it. But I do think this idea of machines that are human-like was just mythology for almost all of human history, even just a few decades ago. Now it's becoming a reality, and we should think carefully, okay, what are the economic implications of that? And some could be very good, some could be counterproductive, and it's incumbent on all of us to understand those implications, because at the end of the day, we have a lot more agency than most people give us. The question is not what technology is going to do or what technology is going to do to us. It's what we want to do with technology. And the only way we're going to be able to answer that is by doing the kind of careful research that you're all doing in this room. So thanks very much for giving me a chance to talk about it again.